Teacher Nanda yet again, and I'm here to welcome you back to GED On. On today's video, we will be covering part 2 of chapter 6, Equations, Inequalities, and Functions. As you may recall, we did split chapter 6 into 2 videos because it's pretty long. Therefore, it's important that you watch part 1 before starting today's lessons. As you already know, GED On was created for you to follow along in the book. However, you are more than welcome to pause and replay the video at any time, whatever works for your needs. Now, let's go ahead and get started with the second half. I wish you the best of luck. Like always, we will be utilizing the Kaplan GED Test Prep Plus 2020 book for this and all GED On videos. You can find links below to purchase this book at your local store or online. Now, let's go ahead and get started. On today's video, we're going to be covering Unit 2, Mathematical Reasoning, Chapter 6, Equations, Inequalities, and Functions, Part 2. We will be covering lessons 6 through 13, which start on page 364. As a reminder, Chapter 6 was split into 2 parts, so please make sure that you watch Part 1 before starting today's video. Now, let's go ahead and get started with the second part. Alright everyone, we're about halfway through. We're now going to move on to Lesson 6, the coordinate plane. Coordinate grids are utilized to locate points that lie in a plane, or a flat surface. A grid is formed by 2 intersecting lines, an x-axis, which is a horizontal number line, and a y-axis, which is a vertical number line. 2 axes intersect at a point called an origin. Each point on the grid can be named using 2 numbers called an ordered pair, which would have an x point and a y point. The first number is the distance from the origin along the x-axis. The second number is the distance from the origin along the y-axis. Let's work through our first example. Example 1. Write the ordered pairs for point M and P. So you can see from our little grid here that we have 2 points. You'll notice one is labeled with an M and one is labeled with the letter P. So essentially we're trying to find the ordered pair, or the X number and the Y number, that would let us know where those points are located. So we can see that point M lies 2 spaces to the right of the origin. So the origin is always 0, 0, so right in the middle. So it lies 2 spaces to the right of the origin along the x-axis and 3 spaces above the origin along the y-axis. So essentially if we start out in the origin, we're going to move 2 spaces to the right, which would put us at 2 along the x-axis. Now, we have to move up 3 points on the y-axis in order to get to M. So this means that our ordered pair for M is 2 and 3. Now P. Point P lies 1 space to the left along the x-axis and 3 spaces down the y-axis. So similar to our number lines, a plane or a grid is also going to have negative numbers. You can also see that both the x and the y-axis have little arrows at the end of their line. So these basically indicate that there's an indefinite amount of points. So in this case, we're going to move to the left 1, which is -1, and then we're going to move down 3, which is -3. Therefore, our ordered pair for P is -1 and -3. Example 2. Point A is located at -2 and 1, and point B is located at 3, -2. Plot these points on a coordinate grid. So you can see I already did it for you, but I wanted to go ahead and explain how I got there. So to plot point A, I started at the origin, as you always should, and I counted 2 spaces to the left along the y or the x-axis because it's a -2. Then I counted 1 space up along the y-axis as it was a +1. So you can see here, plot A is already on the grid. To plot point B, start at the origin once again and count 3 spaces to the right along the x-axis. Then you're going to count 2 spaces down along the y-axis. So you see that point B has already been plotted as well. And that's it. Pretty easy, right? Let's start practice 6, found on page 365. Now that we have completed lesson 6, go ahead and pause the video and follow these instructions. Write the ordered pair for each point. Once you've written the ordered pair on your own, go ahead and click play. So as you can see with this problem, we've already been provided the grid. So now we just have to find the ordered pair for each one of those points. So let's start with point A. Starting at the origin, we can see that it is 4 spaces to the left along the x-axis and 5 spaces up on the y-axis. This gives us a point of, an ordered pair of -4 and 5. Letter B. We can see that B is 3 spaces to the right of the origin and 6 spaces up along the y-axis. This means that the ordered pair is 3, 6. Letter C. We can see that letter C is actually along the y-axis, but it really doesn't move along the x-axis. So what that means is that the x-axis, or the first number of the ordered pair, is going to be 0. However, then you're going to actually move down 3 spaces along the y-axis, which means that the ordered pair is 0 and -3. Now point D. Point D is located 6 spaces to the right along the x-axis and 7 spaces down along the y-axis, giving us an ordered pair of 6 and -7. Now point E. Point E is 5 spaces to the left along the x-axis and 0 points along the y-axis. It does not move up and down. Therefore, our ordered pair is -5 and 0. Now, letter F. Letter F, or point F, is located 6 spaces to the left of the origin along the x-axis and 4 spaces down along the y-axis, giving us an ordered pair of -6 and 4. Now, point G. G is located 2 points to the right along the x-axis and 0 points along the y-axis, as it did not move up or down. That means the ordered pair is 2, 0. And lastly, letter H. H is located 7 spaces to the right along the x-axis and 2 points down along the y-axis, meaning that the ordered pair is 7 and -2. Lesson 7, Graphing a Line. Okay, so now we're moving on to lesson 7, Graphing a Line. So the coordinate system can be used to graph equations. When the equation only has 2 variables, x and y, and neither is raised to a power, the graph of the equation will create a line. A linear equation is when the graph of an equation is a straight line. So let's look at an example. Example 1. Graph the equation y equals 3x minus 4. So in order to graph the equation, we need to solve for 2 points on the line. So remember, we need to essentially solve in order to make ordered pairs. So in order for us to do this, we have to choose any value for x and then solve for y, literally. So we're just going to pick a number. I think it's a little bit easier to just start with a simple number, so I'm going to start with 1. So I'm going to pretend that x equals 1. So if x equals 1 and I were to plug that into our original equation, that would give us y equals 3 times 1 minus 4, which then gives us y equals negative 1. So this is essentially our ordered pair. We have x, which is 1, and y, which is negative 1. Now, we're going to choose another value for x and solve for y again. Because remember, this is one ordered pair, so this is just 1 point. This isn't a line. So we need another point in order to create a line because we're going to connect them. So we're going to do the exact same thing, but we're going to pick another number. Again, I suggest keeping it simple, so I'm going to choose 2. So if x equals 2 and we plug that back into the original equation, that gives us y equals 3 times 2 minus 4. After it's solved, that gives us y equals 2. So this is our second point. So we have 2 ordered pairs now. We have 1 and negative 1 and 2 and 2. So if we were to plot this on a grid, we have 1 point at 1 and negative 1 and another one at 2 and 2. So once we connect those, we can see that it's actually a linear line. It's a straight line. So it's a linear equation. The line itself on the graph represents all the possible solutions for the equation y equals 3x minus 4. Because remember, we just kind of chose random numbers for x. So those 2 arrows that are at the end of the line that we just created stand for all those different possibilities. This indicates that there is an infinite number of solutions for the linear equation. Example 2. Point A lies at 5, negative 6 on a coordinate grid. The graph of which of the following equations passes through point A? So we have 3 different options to choose from. We have y equals negative 5x plus 18, y equals negative 4x plus 14, and y equals negative 2x minus 13. So it's essentially asking us which one of these is actually going to allow us to have the line go through the 0.5, negative 6. Because remember, there's an endless amount of possibilities once it's actually a linear equation that is graphed. So we're going to go back to our guess and check method. So we're going to utilize the ordered pair that's given in the problem and substitute the x coordinate, which would be 5, for x in each equation. And we're going to solve for y. So you think, well, why are we solving for y if we already have an ordered pair that's saying that y equals negative 6? Well, that's not really what we're trying to find. We're essentially trying to find something that, or one of these equations that's going to allow y to equal negative 6. We're trying to find something to prove the ordered pair right. So if y equals negative 6, then the value of the y coordinate from the ordered pair, then you have found the correct equation. So I've already kind of worked through these. So I can tell you just off bat that the correct answer is actually number 2. Y equals negative 4x plus 14. So if we have y equals negative 4x plus 14, and we were to plug in the 5 in place of the x, that gives us y equals negative 4 times 5 plus 14, which then gives us negative 20 plus 14, which then equals negative 6. So this is our correct answer, answer 2. Because it proves our ordered pair to be correct, therefore we know that this particular equation is going to have a line that goes through point 5, negative 6. Let's go ahead and get started with practice 7, found on page 367. At this time, go ahead and follow these instructions and pause the video. Fill in the y column in each table and graph the equation. Once you have worked through this on your own, go ahead and click play. Question 1. Y equals 1 over 2x plus 3. Now you can see that I already filled out the table for you, but I want to make sure that you know how I got here. So we're still going to work through it together. So like I said before, we want to make sure that we solve for the y coordinate. Given that we have an equation and we were provided with x coordinates, that means that we're going to plug in our x variable into this equation in order to get the y variable. Then, hence, creating 3 ordered pairs. So let's go ahead and start. The first row of our table has negative 2, which equals x. So if we plug that into our original equation, that gives us 1/2 times negative 2 plus 3, which is actually y equals negative 1 plus 3. And finally, y equals 2. Hence why there's a 2 in the column for the table. Now let's try 0. Y equals 1/2 times 0 plus 3. This one should be an easy one for you, as you know that anything times 0 is always 0. So y equals 0 plus 3. Therefore, y equals 3. That's our second ordered pair. And finally, y equals 1 over 2 times 2 plus 3, which gives us y equals 1 plus 3. Because remember, if we're multiplying 1/2 times 2, that means that it's 2 over 2. So that's always 1. A number above itself, or a whole number above itself, is always 1. So therefore, our last y coordinate is 4. So now we have 3 ordered pairs that we're going to plot on our grid. So we have negative 2 and 2. We have 0 and 3. And we have 2 and 4. Lastly, we are now going to create a line. So this is the line that is created by this equation. Question 2. Y plus 3x equals negative 1. So we're going to do the exact same thing as before, where we are actually solving for the y coordinates. Now, I've already solved these for you, but I want to make sure that we know how to get to them correctly. So let's do the same process as before. So we're going to take our x variables, plug them into our equation, and then solve for y. Let's start with negative 1. So we have y plus 3 times negative 1 equals negative 1, which then gives us y minus 3 equals negative 1, with the final answer of y equals 2, because we added that 3 to both sides. Next one, 0. Y plus 3 times 0 equals negative 1, which gives us y plus 0 equals negative 1. And finally, of course, y equals negative 1. And lastly, we're going to do x equals 1. So y plus 3 times 1 equals negative 1, which turns into y plus 3 equals negative 1. And finally, y equals negative 4. So now we have 3 different ordered pairs: negative 1, 2, 0, negative 1, and 1, negative 4. So let's go ahead and plot them on our grid. So here we have negative 1 and 2, 0, negative 1, and 1 and negative 4. Now we're just going to put a line between them. Perfect. So the y coordinates that we solve for are then 2, negative 1, and negative 4. We are cruising right along, so let's go ahead and start lesson 8, slope of a line. So you might be familiar with the term slope, or maybe not, but I know for sure that there has been at least one point where you have had to drive up. So if you look at this car right here, we can see that it's going up a slope. So when we talk about a slope, we're actually talking about an equation of sorts. So the slope is a measurement of how steep a line is. The slope measures the relationship between the rise, which is the height, and the run, which is the distance. A line that moves upward from left to right has a positive slope. A line that moves downward from left to right has a negative slope. The slope of a line can be found by writing the ratio of rise to run. So let's look at this through the lens of an example. Okay, so here we're provided with two different examples that we're going to work through separately. So let's start with example 1. What is the slope of line P shown on the coordinate grid? So if you look to the right, we see we have a small coordinate with 1 point, which is labeled P. So essentially what the slope is, it's asking us how far and how high or low, depending on what it is, do I have to go in order to reach the next point in the line? So, step 1, we're going to find 2 points on line P. Then we're going to count to find the rise and the run. The line moves up 1 space for every 2 spaces it goes right. So what this is saying is that if we start at point P, we have to go up 1, and then we have to go to the right 2 times in order to get to the next intersect point. Now, you always count the rise before the run. So what that means is that you always look at how many points up or how many points down you have to go before you look at how many points left or right you have to go. So if we put this into our ratio in our given formula, which is rise over run, that means that we have a slope of 1 over 2. Pretty easy, right? So let's move on to example 2. What is the slope of the line S shown on the coordinate grid? So this one is a little bit different because the points are very separated, but it'll still be the exact same thing. So step 1, find any 2 points on line S. And as you can see, like before, we've already been given 2 points. So the line moves down 6 spaces in a negative direction and then 2 spaces to the right. So if we write this in a ratio format, this gives us a rise over run, which is -6 over 2, which equals -3. Now, a slope doesn't necessarily have to be written in a ratio format because -3 is still an answer. So that is our slope. Example 3. A line passes through points at coordinates 1 and 4 and -5 and 2. What is the slope of the line? So like before, we're going to go ahead and break this down into steps. This is a little bit different, so the way we solve it is going to vary than the previous slide. But let me show you. So our first step is to choose one point to be x and y. The other will be x2 and y2. So the 2's are just to indicate that we have 2 different plot points. Now, we're going to substitute the values into the slope formula and solve. So if you notice, we have y over x, and y is really an indication of the rise. So going up and down, while x is going to be the run. So all we're doing is subtracting essentially one set of points from the other. So we do y2 minus y1 and x2 minus x1. So if we plug in the points that we have been given, we have 2 minus 4 over -5 minus 1. This gives us 1 over 3 once it's been reduced. So essentially this breaks down into -2 over -6, which then further gets reduced to 1/3. Because the slope is positive, that means that the line rises from left to right. The line goes up 1 space for every 3 spaces it moves to the right. So just as an FYI, a horizontal line with a slope of 0 is flat. Therefore, the vertical line is undefined. So that's just something to keep in mind going forward, but as you can see, finding the slope between 2 points is just a simple plug and chug. Let's put our new skills into practice by doing practice 8 found on page 369. At this time, follow the instructions listed, pause the video, and try to solve them on your own. Find the slope of each line. We are given 3 problems. Once you have done that on your own, go ahead and click play so that we may review them together. All right, practice 8. Let's go ahead and work by these one at a time. So let's start with grid 1. We can see that our grid has 2 points. We have 1 point at -1, -2, and another point at 1. Oh, excuse me, let's see. And then the second point is actually at 2, 1. So we're just going to do a simple rise over run. So we are going to want to start at 1 point and then count to see how many times we have to go up and then to the right to get to our second point. So if we start from the bottom, we can see that we have to go up 1, 2, 3. We rise 3, and then we go to the right 1, 2, 3. So this gives us a rise over run of 3 over 3, which equals a slope of 1. Question 2. We have 2 points again. We can see that the top point is at -1. And let's see, it is 1, 2, 3, so -1, 3. And our second point is at 1, -1. So plugging those in order for us to get to that second point, we are actually going to have to go down 4, so that's why it's a negative, and over 2. This gives us a slope of -2. And finally, last question. This one looks a little bit different because even though we do have 2 points, the line is flat. So in this particular case, we're not really rising anywhere. So if we start at the point that's most to the left, we have a -1 and 1, and then the other one would be -2 and 1. But we're not really moving anywhere. So in this case, because it's a flat line, we know that the slope actually equals 0. It's flat, so there's no steepness to it, therefore no slope. Lesson 9, Slope and Equations. Okay, so now that we've spoken about slopes, let's go ahead and move on to slopes and equations. The first thing that we're going to take a look at is the slope-intercept form. So the slope-intercept form allows you to use the slope and a point on a line to find the equation of a line in 2 different forms. So the formula for this is y equals mx plus b, where m equals the slope, b equals the y-intercept. Now the y-intercept, just as an FYI, is the y value at the point where the line crosses the y-axis. The variables x and y are coordinates of any point on the line, which are usually written in an ordered pair. So let's look at this through an example. Example 1. Use the slope-intercept form to find the equation of a line that has the slope m equals 4 and passes through the point -1, -6. So you can see from our grid to the right, we already have it already plotted on our grid. So now we're going to want to go ahead and work backwards. We're going to use the points that we were provided and the slope, and essentially we're going to plug in these values into the formula. So doing that, we have -6 equals 4 times -1 plus b. Again, we're getting the -6 from the ordered pair, and 4 we're plugging in because it's telling us m equals 4. The -1 we're plugging in because we know that according to the ordered pair, x does equal -1. Now, we're going to go ahead and reduce this by multiplying the m by the x. So this gives us -6 equals -4 plus b. At this point, we know that we have to add 4 to both sides of the equation in order to isolate b. This gives us -2 equals b. Therefore, we know that the actual slope-intercept form to find the equation, that comes out to a final answer of y equals 4x minus 2. So essentially the last piece that we were looking for was just that b. Therefore, the 4x equals or minus 2 is going to be the equation of the line that's already on the grid. We're now moving on to point slope form. So this is a different formula or a different equation. This one is y minus y1 equals m times x minus x1. In this particular case, x1 and y1 is an ordered pair that is designated to a point on the line, so a point that already exists there. Similar to the slope-intercept form, m is still equivalent to the slope. Now, simplifying an equation in point-slope form means that solving for y, you will get the slope-intercept form of the equation. To solve this, we're going to follow 3 steps. Step 1, we're going to call the point that you are given. Step 2, we're going to put the x1 and the y1 values into the point-slope equation. And step 3, we're going to put the slope value into the slope or the point-slope equation for m. So this is another just plug and chug and solve. So let's look at an example. Example 2. Use the point-slope form to find the equation of the line that passes through the point 4, 3 and has a slope of 2. So you can see we've already been provided our grid. It already has a line on it, which is great. Now we're going to use that point-slope formula or the form, and then we're going to plug in the values that we've already been given. So in these 3 steps, we're going to do that. So again, x1, y1 equals 4, 3. So using those values and the point-slope form, we have y minus 3 equals m times x minus 4. This further reduces, or then to plug in an additional number, we have y minus 3 equals 2, which is our slope, times x minus 4. Now that we have that, we can further reduce it. So we want to go ahead and get rid of those parentheses. So in order to do that, we're going to multiply 2 times x and 2 times -4. That gives us y minus 3 equals 2x minus 8. And of course, to isolate that y, we're going to want to get rid of that -3. So we're going to add 3 to both sides, giving us a final answer of y equals 2x minus 5. Now let's move on to practice 9.1, found on page 371. At this time, use the instructions provided, pause the video, and try to work through the problems on your own. You're going to use the slope-intercept form y equals mx plus b to find the equation of the line that passes through the given point and has the given slope. Once you have worked through it on your own, go ahead and click play. Question 1. Our ordered pair is 1, -2, and our slope is 4, or -4. So we're going to go ahead and plug this into our slope formula. We have y equals mx plus b. So now we're going to take the variables that we have been provided and plug them in. This gives us -2 equals -4 times 1 plus b. Now, in order to isolate that b by itself, we're going to want to go ahead and add 4 to each side. This gives us a final answer of b equals 2. Question 2. Our ordered pair is -1, -4, and our slope is 2. So taking that same formula of y equals mx plus b, which as you know is the slope-intercept form, we're going to plug in our values. This gives us -4 equals 2 times -1 plus b. To isolate that b by itself, we're going to go ahead and add 2 to each side, giving us -4 plus 2 equals -2 plus 2 plus b, giving us a final answer of b equals -2. And lastly, we have an ordered pair for question 3 of -4, -2, and a slope of 1/3. So using that same slope-intercept form and plugging in our values, we have 2 equals -1/3 times -4 plus b. This gives us a final answer of 2/3. Alrighty, so this particular chapter is a little bit longer, so we do have a different section. So now we're going to speak about slope and unit rate. So the unit rate is utilized to show the relationship between two variables as the ratio of how many units of one quantity there are per 1 unit of another quantity. So in order to solve this, we have 3 steps once again. We have step 1, find the rise and run between 2 given points. Step 2, we're going to write our ratio. And step 3, interpret the meaning of the rate as determined by the slope. So let's look at an example. Example 1. The coordinate grid shows the cost of gas at a particular station. Avery and Beatrice partially filled 2 jerry cannons separately and later graphed the values from their receipts to determine the relationship between the cost, which is y, and gallons of gas purchased, which is x. Determine the cost of gas from the coordinate grid. So you can see that we already have a grid and we already have 2 points. So let's go ahead and do step 1. We're going to find the rise and run. So the line moves up 5, then it moves 2 to the right. So this plugging into our ratio gives us a rise over run of 5/2, giving us 2.5 as an answer. So now we're going to interpret the meaning. That means that the cost of gas at this station is $2.50 per gallon. Now let's look at a few more examples. So for example 2, I have already worked through the problem, but I want to walk you through it step by step. This one is a little bit more complex, so I wanted to break it down for you by kind of just laying everything out on the table. So example 2, a technology company follows a predictable pricing trend, where the price of a new product decreases linearly over time. The company releases a new smartphone at a retail price of $680. The following graph shows the cost of the phone for the next 5 years it is on the market as cost equals y versus time in years x. So we have the 2 steps. Step 1 is to choose any 2 points and use the formula for a slope of a line. Step 2 is substitute the values into the slope formula and solve. So remember that when we're using 2 separate points, we're not going to do our regular rise over run. We're going to do y2 minus y1 over x2 minus x1. So it means the exact same thing, except that we have multiple plot points. So if we pick 2 different points, which in this case, we're going to pick 0 and 680, which is that very top point, and also 5 and 405, which is that very bottom point, and plug those in, it gives us the second line, which is 405 minus 680 over 5 minus 0. To further reduce that, we have 275 negative over 5. Now we know that we can divide 5 into 275, which gives us a final answer of negative 55. So now we're going to interpret this. So as the final answer, it tells us that the smartphone model drops in price by $55 every year it's on the market. Now, those are just the 2 points that I picked, but realistically, you could have picked any points that are given because it's stating that for every year, it drops by $55. So you'll still get the same answer. Okay, example 3. A Minnesota construction company orders limestone, sand, and topsoil from a Canadian company, which chooses the metric system. The purchasing officer knows that there are 2.2 pounds per 1 kilogram of material. He decided to make a graph for reference when making purchases. Typically, he'll buy 100 kilograms, 500 kilograms, or 1,000 kilograms of materials at a time. What will the graph look like? So this one's kind of interesting because they more or less have given us the answer, or at least the values, to work with. So off bat, we know that 2.2 pounds equals 1 kilogram. Therefore, if we already know the 3 different numbers of kilograms that he purchases, then all we have to do is multiply those by 2.2. So that'll essentially convert it from kilograms to pounds. So let's do that first. So the material weighs 2.2 pounds per 1 kilogram. So for 100 kilograms, we convert that by multiplying 2.2 times 100, which gives us 220 pounds. For 500 kilograms, we take 2.2 times 500, which gives us 1,100 pounds. And lastly, for 1,000 kilograms, we take 2.2 times 1,000, which gives us 2,200 pounds of material. So if we were to graph it, we are going to use those same numbers for our plot points. So you'll notice that we have one plot point at 100 and 220. So that's that first set. We have 500 and 1,100 as our second point. And lastly, we have 1,000 and 2,200 as the last and highest point. We are now moving on to practice 9.2, found on page 374. Okay, so at this time, go ahead and follow these instructions, pause the video, and try to work through them on your own. Use the slope formula to find the rates that correspond to the numbers in these scenarios. Once you've worked through them on your own, go ahead and click play so that we can review them together. Question 1. A catering company orders 150 pounds of fresh clams for a banquet serving 100 people, and 30 pounds of clams for a dinner party of 20 people. Determine the standard number of clams per serving. So essentially we're doing the exact same thing as we just did in our previous examples, except that we don't really have to graph it. But we are going to use the same formula. So this one's pretty quick. So using our slope formula, m equals rise over run, we're going to essentially combine the two different variables. So we have pounds to numbers of people. So we're going to start with pounds. So we have 150 pounds minus 30 over 100 people minus 20 people. This gives us 120 over 80, which is then further reduced to 1.5 pounds per person. So in this particular case, the 150 or the pounds of clams are going to take the place of that y-axis, where the number of people are going to be actually listed on the x-axis. So if you did want to go ahead and plot these points, you would be moving up essentially 1.5 up into the right, 1.5 for every point that's on this graph. Now let's move on to our next question. Question 2. A painter uses 15 gallons of interior paint to cover 300 square yards of wall and ceiling space. On a different job, he uses 8 gallons to cover 160 square yards. No paint is left over on either job. How many gallons of paint are needed to cover 1 square yard? So this is pretty similar. So essentially we're comparing two things. We have gallons to square yards. So we're going to use the same example. So in this particular case, the gallons are going to take the place of our rise, or the y-axis, while the gallons are going to be the x-axis, or the run. So if we plug those in, we have 15 minus 8 over 300 minus 160, which then reduces to 7 over 140, which then equals a final answer of 0.05 gallons per square yard. All right, y'all, we're super close to the end. So let's go ahead and move on to lesson 10, systems of linear equations. All right, so let's go ahead and talk about graphing to solve the system of an equation. So linear equations have two variables, as you know, x and y, which represent straight lines in the coordinate plane. Two or more linear equations make up the system of linear equations. Solving a system composed of two equations requires finding the values of both variables. So it's really similar to what we have done prior. The solution will give the x and y coordinates of the point in which the two lines intersect. This can be expressed as an ordered pair. So T-charts. A T-chart can be utilized to solve a system of equations through graphing. This can be accomplished by following the steps below. So we have 4 steps. Step 1 is going to be to create a T-chart for x and y for each equation. We're then going to find two ordered pairs for each equation, and we're going to use x equals 0 to find y, and then use y equals 0 to find x. For step 3, we're going to graph both lines using the ordered pairs. And finally, step 4, we're going to find the point of intersect and express it in the form xy, like an ordered pair. Let's look at our first example. Example 1. Graph the equations 6x plus 3y equals 12 and 5x plus y equals 7 to find the solution. So essentially, again, we're going to make our T-charts for our two separate equations, and then we're going to graph them, which we've already done here, and we're going to find the point of intersect. So remember in our prior slide, we said that we were going to have x equals 0 in order to find y, and then we were going to use y equals 0 to find x. So we're not going to work through these problems necessarily step by step, but this kind of depicts the two charts that we've already made. So you'll see we have split up our equations and they both have charts. So for us to have gotten these points, we did exactly that. We did x equals 0, plugged that into the formula and solved for y, which in our case was 0, gives us 4. And once we plugged in y equals 0, it gave us x equals 2. So that's how we got our plot points for that first chart. For the second graph, we did the exact same thing. We did x equals 0. Once we plugged those in, it gave us a final answer for y of 7. And when we used y equals 0, it gave us an x coordinate of 7 over 5. So this is, again, just listing what we have already done. These particular lines were actually already graphed for us, which was really nice. So you can see from the grid that they do have an intersection point where you see that circle created of dashed lines. If we wanted to write that in an ordered pair, we know that the ordered pair would take us one step to the right and then 2 steps up. Therefore, our point of intersect would be 1, 2. Okay, So now let's talk about substituting to solve the system of equations. Substitution can also be used to solve a system of linear equations using the steps below. So we have step 1. We're going to solve the first equation so that y can be expressed in terms of x. Step 2. We're going to substitute the value of y into the second equation and solve for x. And lastly, step 3. We're going to substitute the value of x into the first equation and solve for y. So again, this is super similar to everything that we've been doing in this chapter where we solve for one thing and we use that answer to solve for the rest. So let's look at an example. Example 2. Solve the equation 6x plus 3y equals 2 and 5x plus y equals 7 by substitution. So we're going to start here with our first formula. Now, what we want to go ahead and do is actually get that y by itself. So remember, that's our first step. We're going to solve the first equation so that y can be expressed in terms of x. We went ahead and did that by removing that 6x from the left-hand side of the equation and moving it to the right. Or another way to look at it is that we subtracted 6x from both sides, now giving us 3y equals 12 minus 6x. If we were to further reduce this would get reduced to y equals 4 minus 2x. So you may be asking, how did we get this done? Well, of course, like always, we want to go ahead and divide to get that y by itself. So if we divided both 12 and 6 by 3, that's how we got the 4 and the 2. All right, so now we have our second formula. However, in this particular case, now that we have y, we're going to plug that into the second formula. So we're going to substitute that in. So we have 5x plus parentheses 4 minus 2x, which again is y, equals 7. This then turns into 3x plus 4. Now we got to 3x because you can see in that first part we have a 5x and a negative 2x. So all we did was combine them or subtract. Now, we want to go ahead and make sure that that x is by itself. So we're going to subtract 4 from each side, which leads us to 3x equals 3. And then, of course, we're going to divide. So then we have x equals 1. We're then going to take that 1 and plug it back into our first formula. So again, substituting. So we're going to do 6 times 1 plus 3y equals 12. We're then going to subtract 6 from both sides so that we can get that y by itself, giving us 3y equals 6. And then, of course, our usual division, which gives us a y equals 2. Therefore, our final answer, or our ordered pair, is 1 and 2. We're now going to move on to practice 10, found on page 377. At this time, go ahead and pause the video to solve the following question. You're going to follow these instructions. Find 2 pairs of coordinates for each equation by making a T-chart, using the coordinates to graph the lines and find the equation. Once you have worked through this on your own, go ahead and click play to continue. Okay, so as you know, for this particular question, it's asking us to find the ordered pairs. Then we're going to graph the lines to the equation and find the point of intersect. As you can see here, I've already filled out the table for you, or the T-chart. So in order to find the ordered pairs, as we covered in the lesson, it's important to make x equal 0, and then plug it into the original function. So for example, if I'm looking at the first T-chart, the one that is most to the left, in this case, when I made x 0 and plugged it into the aligning expression, we would get y equals 3 times 0 minus 15. Now you know that anything times 0 always is 0 at the end. So this would then turn y equals negative 15, hence why it's on the t-chart. Then, in order to get x, you have to make y 0. So if we were to put in a 0 for y, we would have 0 equals 3x minus 15. Then we would need to add 15 to both sides so that we can go ahead and isolate that 3x. So it would turn into 15 equals 3x. At that point, you know that you have to divide by 3 both sides in order to get that x by itself. Therefore, in this case, x would equal 5. We would do the same with the second t-chart. Now that it's filled out, you can see that it has already been graphed. Now, this is kind of a Mod Podge line, but you can see that one of those lines has a positive slope and another one has a negative slope. Now that they have been graphed, we must find the point in which they both intersect. Looking at our graph or our grid, we can see that both lines intercept at this particular point. Therefore, the ordered pair for the intersection is 7, 6. Question 2. We have 4x plus 2y equals 10 and y equals negative 5x plus negative 4. So we're going to do the exact same thing. So again, we are going to be finding the ordered pairs in order for us to graph this particular line, which I already have. And by doing so, we need to make x equal 0 in order to solve for y. Then you're going to turn y into 0 or y equals 0 in order to solve for x. You're going to do that for each of the two equations that we have been provided. So again, for example, taking our first set expression, 4x plus 2y equals 10. If I were to set x equal to 0, this would turn our expression into 4 times 0 plus 2y equals 10. As you know, anything times 0 is kind of canceled out. So this would leave us with 2y equals 10. If we divide both sides by 2, it would give us y equals 5. Hence why the first ordered pair is 0, 5. If I move on to the second expression, y equals negative 5x plus negative 4, if we plug in 0 for that one, it leaves us with y equals negative 5 times 0 plus negative 4, or just minus 4. Therefore, we would be left over with y equals negative 4. Hence why it's our first ordered pair in the second t-chart. Now that they both have been graphed, we need to find the point of intersect. By looking at the grid, I can see that both lines intersect at this particular point. Therefore, the ordered pair in which both lines intersect is negative 3, 11. All right, everyone, we're moving on to lesson 11, patterns and functions. Okay, everyone, so now we're actually going to move into one of my favorite things, which is patterns. So I know that's a really odd thing to say, but knowing how to identify a pattern is actually a really great skill to have. So a pattern is composed of objects or series of digits whose sequence is determined by a specific rule. The rule utilized can be determined by studying the terms that are already provided. Once the rule has been determined, the pattern can then be determined itself. So let's look at an example. Example 1. Find the 7th term in the sequence. The sequence being 1, 2, 4, 8, and 16. So again, we have two steps that we follow. We have step 1, we have to determine the rule or find out what the rule is. And step 2, we're going to apply the rule. So if I'm looking at my sequence, I can see that in this particular sequence of numbers, each numbers in the sequence is 2 times the number before it. So what does that mean? So first we have 1 and then we have a 2. So I know that that the 2 is actually composed of the 1 being double itself. So just like we know that the next number in the sequence, 4, is because 2 times 2, or 2 double of itself, is 4, and so on and so on. So if we know that each number in the sequence is 2 times the number before it, then of course we can find the 7th term in the sequence. So currently we have 1, 2, 3, 4, 5. We have 5 numbers in this particular sequence. So in order for us to get to the 7th, it actually makes sense to go ahead and solve for the 6th as well. So the 6th sequence in this sense would be 16 times 2, which gives us 32. We're following the same rule by the following number, the next number in the sequence being 2 times the number before it. Now that we know what the 6th sequence is, being 32, we can find out the 7th. So we take 32 times 2, which gives us 64. This is our final answer. So 64 is the 7th term in the sequence. Functions are rules that depict how terms in one sequence of numbers relate to the terms in another sequence. Each distinct number that is entered into the function produces a unique output. Each number in the first row relates to the price in the second row in this particular chart. So if you're looking at the chart that we have provided, we have 2 different rows and we have 7 columns. So the 2 things that we're comparing is the number of pizza slices to the cost. So what functions are, what it's telling us is that we're comparing one sequence of numbers, which is the number of pizza slices, to the terms in another sequence, which is cost. So the amount a customer will pay for the pizza is the function of the number of pizza slices the customer orders. So let's go ahead and break this down. So if I'm looking at my chart, I know that for 1 slice of pizza, the cost is $1.50. For 2, it's $3. For 3, it's $4.50. 4, $6, 5, $7.50, and for 6 slices, it's $9. So if you're looking at the cost, it looks like that every time we add a new slice of pizza, the cost goes up by $1.50. So essentially, the cost equals the number of slices times $1.50. Or another way to write this is C equals N times 150, the N being the number of pizza slices. So now we're going to work through some examples together, and we're going to start with example 2. Using the function y equals 3x plus 5, what is the value of y when x equals 3? So that's pretty straight to the point. So let's start with our actual function. Now, because we know that x equals -3, we're going to go ahead and plug that into the x spot in order to solve for y. This gives us y equals 3 times -3 plus 5. Further solving that, it actually equals y equals -9 plus 5. Now if we add those two together, this gives us the final answer of y equals -4. Pretty easy, right? Example 3. Using the function n equals 100 minus 4 times 3 plus m, what is the value of n when m equals 6? So we're going to do the exact same thing, except in this case we don't have a y, we have an n. But again, variables are just variables, so it's the same process. So we're going to take our function and we're going to plug in, let's see, so we have 6 plugged in into the value of m, or where the m is listed. So it gives us 100 minus 4 times 3 plus 6, which is then further solved to equal 9 equals 100 minus 4 times 9, because again, we're just plugging and chugging. Then this turns into n equals 100 minus 36, giving us, of course, a final answer of 9 equals 64. Hey there, I just wanted to go ahead and check in with you. We have now reached an hour of covering this chapter. While the videos were originally not meant to exceed an hour, This is a really long chapter, so we still have a little bit left. So don't give up. Keep going. Let's go ahead and finish this chapter strong. We are now moving on to practice 11, found on page 379. Now that we have finished our lesson, go ahead and pause the video to solve the following 3 questions. Once you have worked through them on your own, go ahead and click play so that we can work through them together. Okay, let's start with question 1. Which number should come next in the following pattern? So the sequence that we have been provided is -12, -9, -6, and -3. So remember that the first step is to identify the rule. So it seems that by looking at our sequence, the numbers are actually increasing by +3. This to me indicates that the next number in the sequence is going to be -3 plus 3, which gives us 0. So it'll now go -12, -9, -6, -3, and 0. Question 2. What is the next number in the sequence? We have 21, 26, 31, 36. So again, we're going to want to identify the rule. Just by visually looking at it, it looks like the numbers are actually increasing by 5. So this would lead me to believe that the next number in the sequence is going to be 36 plus 5, which is 41. Now lastly, in the function y equals 4x plus 10, if x equals -2, what is the value of y? So just like before, we're just going to go ahead and plug in that x into our original formula. So we're going to take y equals 4x plus 10, plug in our -2, giving us y equals 4 times -2 plus 10, which then we're going to further break down into y equals -8 plus 10, giving us a y value or a final answer of y equals 2. Good job, everyone. We are now moving on to lesson 12, function applications. Okay, everyone, let's go ahead and move on to function applications. So functions themselves are pretty diverse and can be utilized for a lot of different business applications, such as calculating profit, cost, employee wages, and taxes. Functions can also be used to make comparisons. So it's a really great application to use in a variety of things, but I wanted to show it to you through the lens of an example. So let's look at this one. Example 1. Celino Advertising is finishing a series of print ads for a client. Finishing the project will cost $2,000 per day for the first 7 days and $1,500 per day after 7 days. The finishing cost can be found using the function C equals 2,000D plus 1,500 times D minus 7, where C equals the cost of finishing the project and D the number of days. If the project takes 12 days to complete, what will be the project cost? So this one's pretty simple in the sense that we're already given an equation and we're already being told what some of these variables stand for. So now we're just going to plug in that information into the formula that we were given. So if we have C equals 2,000D plus 1,500 times D minus 7, we're going to go ahead and plug in that 12 in place of the D. So it's taking 12 days. So this gives us 2,000 times 12 plus 1,500 times 12 minus 7. Now to further reduce that, we now have $24,000 plus $15,000 times 5. This gives us $24,000 plus $75,000, giving us a final cost of $31,000 and $500. So if the project takes 12 days to complete, the entire project cost will be this answer. Okay, let's move on to example 2. Nita decided to join a health club. She gets brochures from 2 health clubs and compares the plans. Health Stars Fitness charges a one-time membership fee of $250 and $8 per month. Freedom Health Center charges $25 per month. At both health clubs, the price P Nita will pay is a function of the number of months M she attends the club. The functions are as below. Health Stars Fitness equals P equals 250 plus 8M. Freedom Health Centers is P equals 25M. So remember, this makes sense because Health Stars Fitness has a $250 fee up front. If they did not, and it was only $8 per month, then we would only see the 8M. So essentially what we're trying to figure out is what is going to be the better deal for Nita. So Nita plans to move in 18 months. If she attends a health club until she moves, which one offers the better price? So we know that M stands for the number of months, so this is going to be very similar to our previous example where we're just going to be plugging in the numbers that we were provided into the equations that were provided. So let's go ahead and do that. So let's start with Health Stars Fitness. If we plug in the 18 for that M variable, we have 250 plus 8 times 18. This then breaks down to $250 plus $144, which together is $394 for those 18 months at Health Star Fitness. Now let's look at Freedom Health Centers. So if we plug in that 18, that gives us $25 times 18, which gives us a total of $450 for Freedom Health Center. So if she's trying to decide which one is going to offer the better price, we can see that there is a difference between both health centers. It's about $50 plus. So given that Health Stars Fitness is a cheaper option, we can then now say that this is going to be a better deal for Nita for those 18 months. Let's go ahead and get started on practice 12, found on page 381. Like always, go ahead and take this time to pause the video and solve for the questions listed below. Once you have worked through them on your own, go ahead and click play. Question 1. The chimney sweep charges $25 for a chimney inspection. If the customer purchases additional services, $15 of the inspection fee is deducted. Let S equal the cost of any additional costs or services. The total cost C of an inspection and services can be determined by the function C equals $25 plus S minus $15, where S is not 0. Jan has her chimney inspected and purchases a smoke guard for $89. How much will she be charged? So this is pretty similar to our actual lesson where we're already being provided the variables, we're being provided the expression, and now it's just a matter of putting in the total amount of additional charges or additional services. So if the expression that we're provided is C equals $25 plus S minus $15, and we know that S equals the cost of any additional services, we're going to plug in this $89 in place of this S, since Jan purchased a smoke guard in addition to getting her chimney inspected. So this gives us C equals $25 plus $89 minus $15. So we're going to do the quick subtraction there. And now we have C equals $25 plus $74, giving us a final answer of C equals $99. So this is how much Jan is going to be charged. Now let's move on to letter B. After an inspection, Ahmed decides to have a new damper installed for $250. How much will he pay? So this is going to be the exact same thing, except instead of $89, now we have $255. So we have C equals $25 plus S minus 15. This turns into C equals $25 plus $255 minus 15. After that quick subtraction, we now have C equals $25 plus $240, giving us a final and total cost for $265. Last question. Ricardo does a great deal of driving for his work. He generally estimates his driving time in hours, t, using the function t equals m over 60, where m equals the number of miles. How many hours will it take Ricardo to drive 330 miles? So again, this is very similar to our first example where we're already being given the expression, what the variable stands for, and also what we're going to need to plug in. So let's go ahead and do that. So we know that our expression is t equals m over 60, and m equals the number of miles. So all we're going to do is plug in that 330 miles in place of an m, and then place that over 60. So once you reduce it or you divide it out, it comes out to t equals 5.5 hours. So this is letting us know that it will take Ricardo 5.5 hours, or excuse me, 5.5 hours to drive 330 miles. Now, for that t equals 330 over 60, you can just divide the 330 by the 60, or you can kind of keep reducing it as a fraction, but eventually you will still get to the same answer. So let's look at B. How many hours will it take Ricardo to drive 255 miles? So we're going to do the exact same thing. We're going to take t equals m over 60, plug in that 255 in place of an m, and this gives us t equals 4.25 hours. So it took Ricardo 4.25 hours to drive 255 miles. We have finally made it to our very last lesson, lesson 13, function notation. Function notations can be utilized to write functions. In function notation, the result of the function is expressed in terms of the variable in the actual function. The domain of a function is a set of input values for which the function is defined. The range of a function is a set of outputs or the results of the actual function. Let's look at an example. Example 1. What is the domain of fx equals 1 over 1 minus x squared? So the domain is a set of values that x can take on to produce a defined value for fx. Thus, division by 0 is undefined. We're going to calculate the values of x that produce a denominator of 0. So in this case, it would be 1 minus x squared equals 0. So similar to before, we want to go ahead and break those apart. So if we break apart 1 minus x squared, or we kind of do a reverse FOIL method, you can say, that would give us 1 plus x times 1 minus x equals 0. Therefore, x equals plus or negative 1. Okay, let's look at example 2. What is the range of fx equals x squared? Like always, we're going to follow a series of steps to solve this. Step 1. Determine the domain of this function. Any number can be squared, so the domain is all values of x. So what this means is that literally every number can be squared, but it also indicates that every squared number is always going to be a positive. So for example, if you were to have 2 squared, that would indicate that you're multiplying 2 by itself, so 2 times 2. You have 2 positive 2's, therefore it only makes sense that your answer would be a positive answer. In the case of squaring a -2, so -2 squared, you would still get a positive number because you are multiplying essentially a -2 times a -2. And as you know, multiplying two negative numbers always gives you a positive. So any number that is squared is always going to be a positive, and that's just something for you to keep in mind. Step 2, we're going to find the minimum value of fx. And step 3, we're going to find the maximum value of fx. So when x equals 0, fx equals 0, and that is the function's minimum value. So that's the smallest it can be. As x moves away from 0, whether positive or negative, so if we were to put in, a -1 or an 8 in there, fx takes on a greater positive value. So there is no limit on how large fx can be. Thus, the range of fx is the numbers greater than or equal to 0. Example 3. Rafael enjoys baking cookies with his nieces and nephews. For every cup of oats, they can make 24 oatmeal cookies. If they made 180 oatmeal cookies today, how many cups of oats did they use? So we're already kind of being provided quite a bit of information. So we know, one, that for every cup, they can make 24 oatmeal cookies, and we know how many cookies they made today. So essentially, we're kind of working backwards. So let's go ahead and write our function. Our function in this case would be the function of c, or fc, equals 24c. Now, the c would stand for the number of cups of oats, and fc is the number of cookies. So if we were to plug in our information, we know that fc is the number of cookies, so we plug in 180 into its place. So we have 180 equals 24 times c. C, of course, being the number of cups. So doing a quick division here, we're going to isolate that c variable. So we're going to divide both sides by 24, giving us a final answer of c equals 7.5 cups of oats to make the cookies. So it takes 7.5 cups of oats to make 180 oatmeal cookies. All right, everyone, let's go ahead and finish strong by moving into practice 13, found on page 383. Okay, everyone, this is our last practice session. Per usual, you're going to want to pause the video and follow these instructions. Find the domain and range of the following functions. Once you have worked through questions 1 through 3 on your own, go ahead and click play so that we can review them together. Okay, let's start with question 1. fx equals x minus 2. So remember that you can replace that x, which is essentially with any number. But the domain is a set of values that x can take on to produce a defined value for fx. So in this particular case, the domain is all real numbers. Range is all real numbers as well. So remember that whether it be a positive or a negative, fx tends to get bigger either way, so it can move in either direction. So this would be inclusive of all real numbers. Question 2. fx equals 5 over x plus 3. So this is similar to our first example. So in this case, the domain is all real numbers except for x equals -3. And the range is all real numbers except for 0. And lastly, fx equals x squared plus 4x plus 4. In this case, the domain is all real numbers and the range is fx greater than or equal to 0. Congratulations, everyone. We made it through another chapter. I know that was a long one, but we have to keep going. Up next, we have Chapter 7, Geometry. See you there.